Okay, hey everybody. I just wanted to really quickly go over the drug study tasks 5 and 6, which are due this week. I know it's been a little crazy, but here we go. Okay, so task 5 is asking you to look at the polarity of your molecule, whatever your drug is. Okay, so you're supposed to redraw the expanded structural formula. So the actual expanded one that you already did, just redraw it. And note the polarity of all polar bonds by drawing arrows, by drawing our dipole arrows, okay? So you're only doing all polar bonds because you're not doing it for every single bond, which means, right, all of your carbon to carbon bonds and all of your carbon to hydrogen bonds are not going to be polar, okay? These guys are non-polar. So you're just looking for things that are other than carbon and hydrogen. All right, so that's the first task of 5. So for example, this is Tylenol, okay? Nice, exciting, very useful, okay? So if I was going to draw the polarity for Tylenol, I'm ignoring all of my carbon to carbon and carbon to hydrogen bonds. I'm only looking for those other elements, okay? So I've got one oxygen, one nitrogen, another oxygen over here. That's it, okay? So oxygen is more electronegative than carbon, right? Remember, Fonkel brush. Okay, most electronegative is fluorine, on down. So oxygen, right here, is more electronegative than carbon, what it's bonded to. So I'll draw my little hole, right? Nitrogen is more electronegative than the hydrogen, than the carbon, and the carbon that it's bonded to. So I'm going to draw 3 arrows all pointing towards that nitrogen, which is a pyramidal shape, right? This is a 3D shape. That nitrogen has a pyramidal shape and it's pulling electrons towards it. So we've got a nice polar situation, right? We've got a delta minus dipole here, okay? And then this oxygen, again, is more electronegative than both the carbon and the hydrogen it's bonded to. Okay, so I'm showing that electrons are being pulled towards the nitrogen, pulled towards this oxygen, pulled towards this oxygen. All right, so that's the first part of 5. Second part, predict if it's soluble in water, if it would be very slightly or insoluble based on the amount of pole bonding, okay? So water is polar, right? H bonded to O, bonded to H, with your lone pairs. Okay, so this is water. Why did I draw in different colors? I don't know, right? Delta minus, delta plus, delta plus. Okay, so water is polar, right? We have a dipole. We've got a negative side, a positive side. Okay, so things that do have polar bonds are going to dissolve in water. So they will be soluble in water. So is this going to be soluble? You would predict probably yes, because I've got some poles. I have things that are actually more electronegative. It's not a non-polar molecule. There are different parts that have poles that are polar. So I would guess yes, it would be soluble. And then you're going to guess if it's very slightly or insoluble. Well, I'd say at least for Tylenol, I'd say it's not going to be insoluble because it's polar. Insoluble would be something that is non-polar. Okay, think like oil. Oil is non-polar. It's non-soluble, right? It does not dissolve in water. Okay? So then you can guess, is it going to be very or slightly? If it has a lot of polar bonds, it'll be very soluble. A little bit of polar bonds, a few polar bonds, it'll be slightly. Take your best guess. There's no right answer. This is a guess, right? Predict. If you have no idea, you got a 50-50 shot. Cool, all right? Then verify water solubility from research. So then you go to the Googles and look it up. Were you right or were you wrong? You're just verifying. So this point right here, this predict, you get points for trying. It's a prediction. I'm not going to mark you wrong on what you guess because then you're going to verify it from research, okay? And then it gives you more information. Okay. Cool, that's 0.5. All right, then 0.6 is hydrogen bonding. Okay? Right, these due dates are a little wonky and off now, all right? But hydrogen bonding, note if your drug molecule does or does not have hydrogen bonding. So then it just tells you what hydrogen bonding is, okay? If I have hydrogen bonding, I circle it. That's it. So I have to look and see, is a hydrogen bonded to the first three, F, O, or N? Aha, here's a hydrogen bonded to an F, O, or N. So right here, I have hydrogen bonding. None of my other hydrogens. Oh, another hydrogen, right? Got to make sure you check your full molecule, right? Huge mistake that is made is if you only circle one, you're like, ooh, I'm done, okay? Double check. Don't miss the other one that's in there, right? So here's a hydrogen bonded to a nitrogen. Aha! Circle it. Another hydrogen bonding. Are there any other hydrogens bonded to F, O, or N? Nope. So here we go. So I'm done. That's it. Okay, tasks 5 and 6 for your research. Good luck.